Okay, so this panel session is going to put this all in end user perspective, especially with the help of Honda, representative from Honda here. We're going to talk about high performance computing in the cloud. So how possible is it to spin up a supercomputer in the cloud? You know, who's doing it? Why? What are some of the challenges? Hopefully we can address a few of those things and some of the main themes. We're joined today. We have Ayumi Tada. She's in charge of high performance computing at Honda. We have Dave Pellerin. Right next to her, he's business development for HPC at Amazon Web Services. Next to Dave, we have Deborah Goldfarb. She's a chief analyst and senior director of market intelligence at Intel. And at the very end there is Ray Milham. He's VP of enterprise solutions at Ansys. So we've got the ISV perspective, Amazon perspective, Intel, and of course Honda. So let's start with you, Ayumi. I think a lot of people are really curious about what the infrastructure looks like at Honda, what the history, is there something I can do about that? What's the background at Honda in terms of high performance computing?
Yes, Honda has many products such automobile and motorcycle. Since 6 or 7 years ago, we had been consolidated our HPC system at our big data center, and we reduced cost. And I belong to IS department, and my responsibility provide IT resources to internal researchers and developers. There are tens of thousands of cores at our data center, and we have those of thousands of users. And so we have a lot of cores, but our cluster are allocated for each group of users who share the same usage purpose and cores and purchased by department. We want to use our resources more efficiently, but it is not easy because our user is little not flexible sort, and the other is operation. Operation is limited. So users always want to ensure efficient resources. They know that they can't get their resources easily and immediately. So they want to keep maximum resources required at the peak time. Users don't want to share their resources with other departments, even if they don't use it, because they can't accurately predict how many nodes they need at what timing. Actually, if users want to buy new resources at on-premises, they have to wait over 3 months. It takes much time to procedure to purchasing resources. And sometimes they request additional resources suddenly. Of course, we coordinate and answer to their requests as far as we can. However, we cannot handle all requests at on-premises, and we had been unable to get out of this situation.
Absolutely. So from procurement cycles to management to just getting the cluster in when you have time to market demands, I'm sure I definitely see why the cloud is important here. Can you talk more about how it's been leveraged at Honda? What types of modeling and simulation applications are you handling, and what have some of the advantages and challenges been there?
Okay. There is much leverage with using cloud. Cloud made our situation better, as I just talked about. The biggest benefit is that user service got better. On-premises resources are limited. So if resources are used up, they cannot compute when they want to. Cloud capacity also has a limitation, of course. However, it's so high capacity that users can compute at an appropriate timing. That is, cloud can change users' thought. They don't need to keep their resources. They can use resources easily when they want. There are over 100 applications in total, and users are asking different sets of hardware for each application. And we, as an IT department, were not able to handle too many requests. So we needed to standardize system server to reduce the process. This is not ideal for users, but users endured traditional systems. But thanks to cloud, now we can extend the range of choices for users, and users can choose suitable resources for their application from several services. Users' experiences were significantly improved thanks to cloud.
Mm-hmm. Absolutely. I know that you've had some challenges just in conversations that we've had leading up to the panel about some of the business business case challenges in terms of talking to your company about it. And all of us have had conversations about this. I know that certainly, Deborah, you have some perspectives on making the business case for cloud. If you could share some of those.
I sure can. So, when I came to Intel, something that we were very passionate about, and I spent the better part of my career in HPC around, is how do you extend high-performance computing into the broader marketplace. We called it the missing middle, or how do you activate people who've been not having access to computational resources, how do you provide access? And that has been clearly kind of a governing thought about the role cloud might play. But I want to pull back for a minute. I'll come back to this point when we talk about how we're looking at the cloud broadly from Intel perspective and how we shape the market, how the market is shaped from our perspective. But I think we need to really consider the fact that people think about HPC in the cloud in a variety of ways, right? So, one of the primary ways is they're looking at the same metaphors we exist today of how do you take your existing workload and you move it to the cloud, right? So you're thinking sort of you have a static workload, how do I move it dynamically? And that's some of the work that Honda's doing, right? So they're looking at their workload, they're determining how they leverage the cloud and that as a computational platform to move their workload. But what if, before I get into how Intel thinks about the market, but what if we flip that? And what if we actually consider the fact that how would it change our point of view if the governing principle was, what if we had infinite computing power? How would it reshape the way we think about problems, the challenges we face in our own data centers, and the applications that we're facing? What would that look like? How would we rethink that? So from an Intel perspective, we look at the market in 3 big buckets when it comes to HPC in the cloud. The first is users who understand HPC. They're explicitly using this infrastructure today in a static way, and they're beginning to think, how do I begin to move some of my workloads into this cloud environment and take advantage of this different paradigm, right? More infinite, being able to do bigger applications, more iterations and whatnot. The second group are people who are part of this missing middle construct, right? People who may be sitting on a desktop or a workstation, they don't have access to computational power, and the cloud suddenly becomes this democratizing force, okay? So how do we reduce those barriers to access, reduce the cost points, and make it this frictionless experience? And from an Intel perspective, we're focused really, really heavily on what are the things that we need to do as a company to create this frictionless environment. What are the tools, the underlying infrastructure, the technologies to create this seamless experience? The third bucket, which is really extremely exciting, certainly from an Intel perspective and me personally, is this idea of implicit HPC, where HPC is a service that gets leveraged and rendered across a whole bunch of services in a cloud infrastructure, so that the user has no idea that HPC is running in the background. It becomes this ubiquitous ubiquitous asset. And you could think of all sorts of really exciting use cases around this in the medical field, connected health, autonomous vehicles, consumer-based applications that are just going to become pervasive. So we look at sort of that taxonomy totally. With a couple of things in mind as operating principles. One is how do we create usability, reduce barriers to access. The second, it is high performance computing, so performance is always, an important, we need to be very, very mindful of how do we make sure there's performance at the core, enabling people to do the things they couldn't do before.
Absolutely. Dave, you talk to a lot of customers. I think you're at every single HPC event that exists most of the time. Are Deborah's experiences similar? Are her thoughts resonating with you in the same way?
Absolutely. And reflecting back on Tada-san's comments around Honda as well, when we think about performance, do we think about performance in terms of one application and one server or one cluster that it's matched to? Or do we think of performance in terms of time to results, right, of a complete workload? Increasingly, that's what we're hearing customers telling us. It's really about getting faster time to results for their broad workflows in HPC. And often that involves very wide parameter sweeps. We saw an example this week at HGST, a disk drive manufacturer assisted by cycle computing, where they hit 70,000 cores at peak, something they wouldn't have been inconceivable to them a year ago, right? And that's an example of very large parameter sweeps where they're parallelizing so many jobs and pulling in that time to results. So performance, again, it's not just what is one application's performance on one set of servers in a cluster. What's the overall performance in terms of results delivered to an HPC customer? And that's what cloud is really delivering.
Mm-hmm. How does Honda consider performance? I'm sure it's a matter of time to solution and all of the typical ways that you would measure progress. But how do you think about performance at Honda when it comes to cloud?
I think cloud services are still growing, so there are a lot of spaces to be improved. When we started investigating AWS Cloud, we found we needed more network performance for our computation. So we requested to AWS what kind of network performance needed. Then they responded to it quickly, very quickly. For example, interconnect network speed between multiple computing nodes used to be very, very slow. But after C3 instance was released, the current services are much better than before. In result, some applications which need parallel processing get enough network performance, and we can bring it to cloud. Of course, I wish we were even much better, and at the end of the day, we want to run everything in the cloud. So anyway, my point is you have to know you does not need to give up. When you face the performance issue of cloud, rather, you just need to tell what you need in the cloud. And you can believe AWS and other cloud providers will quickly respond to the request.
Mm-hmm. There are no other cloud providers. Dave. Dave stiffens up when you say that. So even with running everything in the cloud, and I know that that's your goal and vision, and you're very vocal about the applicability of cloud for manufacturing for HPC applications, there are certainly some barriers and limitations. And it's not just a matter of network performance and latency. There is a software and ISV licensing challenge for HPC clouds. And Ray, I know that you're very close to this topic as both a vendor and someone that works with manufacturers. Can you speak to that?
Sure. Great question, Nicole. Thank you. As an ISV vendor, ANSYS definitely believes that a lot of our customers are gradually moving their HPC to the cloud. A lot of different complex use cases, as David alluded to. So sometimes customers are using mechanical simulation or electronics or CFD, computational fluid dynamics, to move it to leveraging HPC in the cloud. We also see that, as IDC, one of the quotes mentioned that HPC is increasing in the cloud. I think it was a few years ago, 10%. Now it's almost 25% of HPC users are moving to the cloud. So we definitely believe that Amazon has a lot of different pieces, and they're on the right track for sure as far as the moving HPC to the cloud. As Tada-san also mentioned, that the things will be gradual. There will be a lot of use cases where customers might continue testing on site, but then eventually test it on HPC on the cloud. and then leverage, check out things like performance, latency, to ensure that their workloads are done, and then time to market, for sure. Time to results, which really is time to market, is very, very critical, as David alluded to. And technology-wise, as Deborah mentioned, Intel and other technology companies we work with, they're looking at next generation for HPC in the cloud. How do you continue having lower latency, high bandwidth, high performance? So absolutely, as an ISV, we definitely believe that it's a gradual process. HPC will happen on the cloud, in addition to all other services associated with that. Scalability, obviously elasticity that ties into many other business things that we'll discuss as well.
So. I have a follow-up, Ray, if you don't mind. So you being the only ISV on the panel, I can ask you, and maybe you can speak for ANSYS and maybe some of your cohorts. The industry, the ISV industry in HPC is a cottage industry, and it's very much shaped around serving static infrastructure. So how do you see the licensing models evolving? Is ANSYS ahead of the curve? Are you right in the curve? Do you believe your peers are thinking similarly about how to change the model to really allow for that broader use case of people leveraging the cloud in much more mini bites?
Thanks, Deborah. Excellent question. I mean, we definitely have a vision to test and evaluate a lot of things on HPC and on the Amazon cloud. On the licensing side, for sure, that we also have a vision as far as having customers the flexibility to have the traditional licensing, whether leased and paid up, or the elastic usage of licensing as well. So we believe that it's also a gradual thing. Nothing happens overnight. It's going to happen within, hopefully a year or two, that us and probably other ISVs and the whole market will move to this usage or elastic-based, licensing, giving the customer base the flexibility to keep traditional licensing on the cloud or have traditional licensing plus the usage or elastic licensing.
Right. Dave, when you have conversations with HPC end users, what are their concerns around the software and ISV challenges? Not just scalability, obviously, but the business models behind the software in the cloud.
Yeah, it really is one of the first questions that's asked by potential HPC customers and current HPC customers. How supportive will their ISV partners be in deployments on the cloud? Technically, in the ability to support the software, to get the performance that's needed on a sort of a per core basis, and then the flexibility of the licensing models. I would say ANSYS is quite a progressive vendor in that way, right? So there are many vendors out there that are still, licensed per core. That's a traditional model of licensing that really assumes a fixed size of infrastructure and not this highly scalable infrastructure that's possible in cloud. Vendors like ANSYS, though, are moving quickly to having a blend of these models, right? So they may have existing subscription-based models that are useful and cost-effective for large organizations running maybe 24/7 kinds of simulations, and then combining with that perhaps some token-based or other model of scalability in the cloud. I think we're seeing a strong movement toward that in mechanical CAD, in CFD, in other domains. And there are some domains that are a bit slower to move, but I think over time, all of the industries that consume HPC today, certainly in the engineering sector, will see this change and benefit from that scalability.
Right. How significant were the challenges at Honda when it came to getting your software to run, either scalability-wise, business model-wise? Because I know you're using commercial, proprietary, or commercial codes for a lot of your engineering work. So
we want to use our existing licensing for any resources, so on-premises and cloud. But we can't use most of our licensing for extra resources. We have to buy new ones for it. So we are asking major ISVs to allow us to utilize our license for any resource. So some of ISV addressed our request, and they allowed to use existing resources. But I think that it is not enough. It should be more improved. Honda is a global company, And cloud is empowering our global development. However, traditional license restriction does not work in our situation. For example, users can use the license within a specific distance from a license server, etc. So we are asking major ISV to allow us to utilize license globally and from any users. This is just an example, but I appreciate ISV understands our needs and improve their licensing.
Yeah, absolutely. Well, let's play a game here. Let's fast forward 5 years. What does HPC in the cloud look like? And you can take that on a technology bent, on a cultural bent. You're all grinning a little bit. Dave, I know you have thoughts. I'm sure Deborah does too. Deborah, you want to start?
Sure, Deborah.
Sure. So predictions are fun because you can say anything. 5 years is a long time. It's a short time also in terms of evolutions. But actually, if you look at the underlying trends here, the economic drivers, the broader trajectories in sort of the broader industry, and you take a lap around the show floor, and you really can feel what's happening here. We're at a sort of major shift in the industry. And whether it's 5 years or 7 years, I think that sort of the die is cast on what's going to happen. And so if I look at where I see the real things that are going to happen, I think within around 5 or so years, you will begin to see this frictionless access to the cloud. I mean, certainly from the things that we're going to be sort of driving into the market and instantiating sort of clusters at the platform level, so that users will not have to get in and sort of mechanically tune how they think and access what a computational resource needs to look like for specific types of applications. So there's going to be things that will really drive that ability to seamlessly access cloud resources. I think that'll become really common. I think that every CIO, CTO, head of R&D is right now beginning to look at their workflows. They have to be. Looking at what's going to stay in a static infrastructure, what's going to move to dynamic infrastructure, and they're looking at the ROI and the TCO around all those workloads. And they're making decisions. They're going to try some things out. They're experiment. They're going to begin to move workloads into onto different platforms to see how they respond to these kinds of environments and what kind of ROI they get and the kinds of opportunities it affords them. As I mentioned before, if you flip this upside down and you think about infinite possibilities, how does it begin to change the foundation of the things you do in your data center, right, that drive your top line? So, so if I were to fast forward, I think that HPC in the cloud, it will become less of a, gee, this is unique and experimental, and much more of something that becomes rationally driven into the decision-making of any R&D center or people doing analytics. Back in this notion I mentioned earlier of implicit, where HPC becomes an embedded service, if you look at what's happening globally in emerging economies such as China, where it's first of all, it's a cloud-first. It's cloud first because they don't have the legacy infrastructure. And it's really about mobility to cloud. And you look at the kind of workloads that are being driven there, you will see implicit HPC driven through these machine learning and cognitive platforms becoming pretty standard. And I would expect that in 5 years, that will be very, very much ubiquitous in a lot of these environments. Thanks.
Yeah, absolutely. Dave.
For a cloud provider, for AWS, I mean, 5 years is a very long time. You've seen this morning the pace of innovation, how much comes out, how quickly. So it's very difficult to predict that far in the future. But what we can say is that, we're at a point now where we're making a fundamental change in how HPC consumers think about where HPC occurs and when. Deborah used the term earlier, embedded, right? Intrinsic computing for HPC. And we're seeing that everywhere. We're seeing it in object recognition applications. We heard it this morning in the keynote in regards to liquidity simulations for insurance companies, right? These are workloads that really didn't exist or we didn't think of as HPC perhaps even 5 years ago, 10 years ago, and now they're a critical part of a business, of an industry like insurance, financial services. Architectural simulations now are happening at a massive scale that didn't happen 10 years ago because of need for energy efficiency, right? And for safety of products. HPC is becoming embedded in workflows across industries, not just the traditional workflows that we think of them. And so enabling them in the cloud through advanced services, through friction-free ISV deployments on the cloud, very, very important. Where we'll be in 5 years, perhaps we won't be talking about HPC. We'll just be talking about big compute and all of the things that we're able to do by deploying massive numbers of CPU cores at a problem on demand to solve problems very quickly, making it almost an interactive process of running these huge simulations.
Right. Ray, you're grinning over there. I know you have something to add.
Yeah, excellent question. I mean, God knows what will happen in 5 years for sure. But it's the first paradigm shift, as David and Deborah mentioned, is happening already in front of our eyes with on-site to cloud at 50,000-foot level. And then clearly, gradually, this evolution moving in our world, the simulation, CAE, and CAD and CAM world, this evolution is happening. It's really not a revolution. I think it's definitely happening. There's a paradigm shift from the on-site to cloud, which is happening, but it's also an evolution. I think specifically on the technologies, things will change for sure. Who knows, 5 years from now, the technologies under the hood, like with Intel or other semiconductor providers, they will have new technologies empowering all the instances on AWS, EC2, ultimately providing high performance for customers like Tada-san. And you know, to David's point, it could be also embedded, like ultimately customers, we have to find a solution to make it very easy for the customers to move complex simulation engineering to the cloud, to make it as interactive as possible, to make it as flexible and agile as possible. So I think, you know, the next 5 years there will be a lot of changes for sure, technology-wise, hardware, software, different APIs, different technologies that are coming up that we have not thought about today, that somebody somewhere in startup somewhere around the world is working on it. And ultimately, it's all about make sure that the product, you have accessibility to the resources, you have accessibility to high cores, make it easy and flexible for the customers. So yeah, I mean, it's definitely going to be some evolution happening, and it's things are happening every year. You know, as David mentioned this morning, I learned a lot about new offerings that AWS has, and you know, all of us combined, vendors, customers, users, I think we are contributing to all these changes happening HPC on the cloud and the cloud in general. Mm-hmm. Thank you.
But this isn't just a matter of technology and automation and abstraction of all these different layers. It's also a cultural issue. For high-performance computing end users, traditionally, this is a very segmented world. I think that anyone that's lived in HPC to some extent realizes that the on-site cluster is it reigns supreme. So there's a cultural thing to get over. You and I had a great conversation yesterday, Deborah. I'd love for you to recap this quickly about how this is very familiar to other movements that you've seen. I think it's a great point if you could share.
Sure. Mm-hmm. And yes, there is kind of this iconic notion of HPC, which actually is quite a very, really small subset of the overall HPC market. But you know, I spent the better part of my life as an analyst, you know, about 17 years. So I think this way, in terms of history, is a wonderful way to anchor yourself in perspective, right? And so, you know, technology transitions happen, you know, at a regular pace, right? You have evolution from the mainframe to Unix servers, and I remember it very well, where people said, oh my goodness, we will never put mission critical workloads on that Unix server. No, no, no. What was the strategy of the Unix server vendors? Surround the mainframe. Let's capture net new footprint, non-mission critical workloads, and over time, within about a decade, most of the mission critical workloads were sitting on Unix servers, and the minute the database went to the Unix server, it was over, okay? Because data began to really reign premier, right? And so the sort of the concentration of spending, the concentration of control moved to that Unix server. And the same phenomenon happened when things moved off the Unix servers onto x86 servers and clusters. And one of my colleagues at Ford would literally say, clusters are breakfast cereal. I will never put my HPC on a cluster. And if you go around Ford Computational Data Center today, there's almost only x86 clusters. The point I'm making is that evolution's happening, evolutions continue to happen, and there's nothing unique here, except that we're in another one of these fairly significant inflection points in technology transitions. I think the important things that are going to happen here that are going to really move us forward, I think, at a much faster rate are one is, if you look at cycle times between technology transitions, they've been happening faster and faster, okay? Mainframe to Unix server to x86 cluster, there's been a contraction in time, that's number one. The second thing is this phenomenon, what's happening globally around mobility, is driving behaviors that are very, very unique. If you go to, as I said earlier, if you go to China, the legacy, we're thinking very first world here, okay? There is not the legacy kind of infrastructure that we have in places like Europe and the United States. So it's a cloud-first culture, okay? There's this gigantic momentum, not only from a workload standpoint, but just the energy of where dollars are moving. If you talk about machine learning, it is happening at a warp speed in China because they know that there's this need to drive intelligence into this digital economy infrastructure to automate these resources and these processes and the economy overall. So there are things that are happening kind of outside the traditional HPC space that are really driving momentum into the use of these advanced platforms to do all the things that we're talking about here. And last but not least, and it's important for the industries that we all serve in HPC, is that there is a pretty significant generational turnover that's happening as we speak. If you look at manufacturing, oil and gas, I mean, we are at an inflection point, if you will. I hate that word, but it really is. We're going right off the edge in terms of people retiring. So there's a completely new perspective on the role of things like cloud and new kinds of infrastructure to run these workloads. So I think we're not necessarily going to be encumbered by the same kind of metaphors that have existed, historically.
I want to add just more data point, if I may. Thanks, Deborah. Excellent points. I mean, I also forgot to mention that some other software vendors like Cycle Computing and other companies like them are doing a lot of innovation in HPC clustering, scalability, provisioning, monitoring, etc. That will allow also the increase of the HPC adoption on the cloud. So that's also another critical point. Thank you.
Absolutely. Dave, are her words echoing with you here?
Absolutely. And 2 points here. I'll follow up on Ray's comment in just a moment about partners because they're so important. But to reflect, Deborah's comment about the inflection point, a lot of us who are probably on the verge of falling off that cliff due to retirement soon, remember there was a time when the ISVs in CAD, CAM, CAE, EDA, name your space, offered not only the software, but the platform on which it ran. It was a vertically integrated solution. In some cases, they would design and build the workstations to suit the particular application. When Unix and Sun came along, the new platform paradigm, that all changed, right? Many vendors survived, some didn't through that change. So the vendors there were agile and quick and able to take advantage of the new scale, if you will, of economies of scale of working on departmental clusters and workstations that were more general purpose was a huge enabler. And then came the Beowulf cluster time where we had additional economies of scale. So what we're seeing now with cloud is such a dramatic increase in the economies of scale and the rapidity of the innovation that has generated this entirely new way of thinking about HPC. As I said earlier, time to results due to scalability, massive parallelizing of parameter sweeps, other ways of getting advantages of the scalability and agility that you didn't have in any of these prior platforms. And then to follow up on Ray's comment regarding platform partners, very, very important. We have many partners out there here today and of course in the community supporting HPC for various industries, the vertical specific HPC expertise, those that have, like Cycle Computing, some great IP for scalability, for example, using spot instances. So definitely partners are a very, very important part, and ISVs, of enabling future scalability and benefits to customers of HPC in the cloud.
So what does Honda's HPC infrastructure look like in 5 years? Amy-san.
I think it will be perfectly normal to use cloud for HPC. However, it is fact that we have lots of challenges we have to overcome. So that is not only technical challenge, and that I just asked you. But more importantly, we need to change our thought, so cloud users' thought on cloud and its operation. It's cloud user who will provide feedback to AWS cloud and improve the cloud. And it's cloud users who will determine how fast cloud improves. It's all up to cloud users, I think. I hope cloud will grow so that Honda and other manufacturers can focus more on research, development, and manufacturing.
So you believe then in 5 years, HPC infrastructure will be mostly cloud at Honda?
Yes.
That's really something. Okay, excellent. Check my time here. Is that okay? All right, so I do have one last question. Let's move back to some of the challenges that we all talked about a little bit. So we've talked about some of the technology challenges. It seems to me like the business case, making the business case, proving out the TCO, seems to be the biggest challenge for clouds. Is that so in your experiences, your conversations with customers?
I can talk briefly about that. That's absolutely a part of any conversation with a large enterprise customer or research customer in considering which workloads come to the cloud. And we have some fairly deep bench, some expertise in helping customers understand the TCO of running on-premise HPC versus running in the cloud. And it's so important when we do these analysis that we think about utilization. We think not only about, as I think Deborah mentioned earlier, not just doing what you're doing today on-prem in the cloud, what's the sort of like-for-like comparison, but what's the value of agility? What's the value of significantly greater utilization? And another aspect of this that Tadasan mentioned earlier is right-sizing of a cluster, right? So it's one thing to stand up a general purpose, if you will, HPC cluster and equip it with some middleware to handle the job queues and so forth that's perhaps built for the worst case application. But it's a very different environment if you can move that to the cloud and run each workload on a purpose-built on-demand cluster of exactly the right size and shape of instances, the right amount of memory, the right storage I/O, bring it up, tear it down when you're done with it, and don't pay for it when you don't need it. Completely different model, and that must factor into these TCO discussions, and it often does. And when those discussions are made, it's just, as we've heard this morning in the keynote, some of the cost savings are just dramatic when utilization is brought into the discussion as well as just like-for-like workloads.
Mm-hmm. Yeah. Mm-hmm.
So I completely agree with what you're saying, Dave, and I think a couple of things would be really interesting at an industry level, which is we begin to actually codify ROI and TCO for different classes of workloads so that there are clear benchmarks out there that end users can actually reference when they're doing their own internal analysis. That's one. I think that would be a massive step forward to actually begin to think about that cohesively. I think the second thing is, and sort of riffing off of your point about right sizing and all these other things, and how do you think of the overall end state in a coherent and cohesive way? You know, if you're trying to drive to a global R&D environment, much like what you're doing at Honda, the cloud becomes this amazing collaboration platform, and no one's yet quantified what that impact is and how you communicate with your supply chain and how do you create common models across that supply chain. So back to like how do you get standard metrics around TCO and ROI and the overall economic benefits of this movement. You know, maybe there's BKMs we could begin to share and get those codified. I think that would be a really huge step forward. And every industry is going to be bumpy. Some are going to accelerate faster and some are going to be slower, but you know. Right?
Yeah, thank you. Yeah, it's an excellent question. I think the way we view it, and definitely it's both technical and business for sure. As total cost of ownership, it is business for sure, but it has a technical aspect. How do you enhance your design? How do you ensure that you have the right workflows? How do you ensure you have the right instances in the case of AWS and the cloud? How do you ensure that you have, like if you're testing, for example, other things than just HPC, like remote visualization from companies like NICE and other companies out there, you want to make sure that total cost of ownership has the business and the technical side totally connected. And then the other aspect is partnership. Like, from our side as an ISV and as ANSYS in the CAE simulation world, working closely with customers, working closely with different vendors and AWS, looking at that whole, what is the return on investment, especially when we're dealing with Chief Information Officers, CIOs. So I think it's definitely it's something that's very valuable, and looking at the TCO comprehensively, not just from a pure business, money, short-term, quarter by quarter, looking at it in a holistic way, year after year, and definitely with a technical aspect to it. Because the last thing you want as a user or as a simulation engineer or analyst is to ignore your technical guys, whether it's IT or the simulation engineer in our world. At the same time, you don't want to ignore your CFO, who has a certain budget and is moving some of the workload, HPC on the cloud, and want to do that end-to-end simulation. So that's a very critical point, actually. I think it's really a collaborative effort between us as an ISV, customers, AWS, Intel, and other vendors in the market. It's definitely also, there are resources available that we're working closely with AWS and other companies to evaluate them and put a $ on these things.
Yeah.
Thanks.
TCO is probably the most interesting topic. It's so variable between different applications and users. We could do an entire different panel on that subject. Unfortunately, I do believe that we are out of time. So thank you, everyone, for coming to the panel today. Thank you, Ayumi-san, Dave Pellerin from AWS, Deborah Goldfarb from Intel, and Ray Milham from ANSYS. Thank you very much.